Namaste. The title of the current study is Effect of SNR and Reverberation on Speech Perception of School-Age Children, presented by myself Ananya Kanigalpula, a postgraduate student from All India Institute of Speech and Hearing, Mysuru, and co-authored by Dr. Nisha KV and Dr. P. Arivudai Nambi. First, let's look into the background and need for the study. Majority of classrooms in India are not devoid of reverberation and noise. Several studies in the past have shown how the reverberation and noise distort the speech signal and hinder comprehension. Since the primary modality of instructions in schools is through audition, this affects the child's learning process. Thus, the current study seeks to provide a comprehensive understanding of how reverberation and noise influences the child's ability to perform in the presence of co-located and segregated noisy situations. Let's look into the aim and objectives. The aim of the study was to investigate the effect of SNR and reverberation on speech recognition in school-going children aged 8 to 12 years. The objectives were to compare the spatial advantage in speech recognition scores across two SNRs, two reverberation times, and three distractor locations. Let's look into the methods part. 36 typically developing children in the age range of 8 to 12 were considered for the study. All had Kannada as their mother tongue, and the test administered was spatial separation sentence test. Informed consent was taken from all the parents, and the study was approved by Aish Institute of Review Board. The inclusion criteria was all the children were attending regular schools with age adequate academic skills and had normal hearing thresholds in the speech frequencies. Children with presence of processing disorders such as CAPD or dyslexia or other comorbid psychological or neurological conditions were excluded from the study using the following screening tools. The demographic details are as follows. There were 22 males and 14 females, and all the mean and standard deviation scores of all the screening tests used are listed here. Coming to the reverberation time measurements, three different schools in Mysuru were selected for the reverberation time measurements. The average RT20 value was calculated, which was extrapolated to RT60, and short reverberation time was calculated as average RT minus 2 standard deviation across the following frequencies. Looking at the stimulus generation using the dimensions of the schools and the reverberation time and ARI HRTF database, spatialization and reverberation were incorporated simultaneously in the MATLAB software. The three distractor locations were 0 degree, plus 60 degree and minus 60 degree, and the source location was always 0 degree. Two SNRs were also considered, that is 0 dB and plus 10 dB SNR. The task was initial 5 minutes there was practice trial given with 0 dB SNR, average RT and co-located condition, and for the actual trial there were total of 12 conditions and 10 sentences in each condition, that is total 120 sentences. The keywords of each sentence was scored, so maximum score was 10 was possible for each condition. Adequate breaks were given after each trial. Following are the 12 conditions used. Later, spatial advantage score was calculated. That is, it is the difference in the speech perception accuracy between the segregated condition and co-located. That is 2 years in 2 RTs and 2 SNRs. Total of 8 data points were obtained. Under statistical analysis, normality test was conducted. Repeated measures ANOVA was done to study the main and interaction effect, and paired t-test was also carried out. Now let's look into the results part. The following table shows the comparison of speech perception score across two SNRs and two RTs in the 3 different distractor locations. Chaparro-Wilk normality test revealed that the distribution was normal. Repeated measures ANOVA showed that there is a main effect for SNR as well as RT, and interaction effect was present between SNR and RT. Further, paired t-test was carried out for both SNR and reverberation time. First, let's look into the SNR comparisons. So, total four comparisons were carried out. The first comparison was between plus 10 SNR and 0 dB SNR when with average RT and distractor in the right ear, and there was a significant difference in the score. Second comparison was in average RT condition with distractor in the left ear, and there was no significant difference in the plus 10 and 0 dB SNR condition. Third comparison was between plus 10 SNR and 0 dB SNR with short RT and distractor in the right ear. Here, this difference was approaching significance. And finally, the comparison was between SNRs for short RT and distractor from the left ear. Here, there was no significant difference. Now, let's look into the comparisons for reverberation time. Since we can see that the p-value was greater than 0.05 for all the four comparisons, we can see that there was no significant difference between the average RT and short RT, irrespective of the SNR and the year of distractor location. Coming to the discussion part, we can see that there is better spatial advantage in 0 dB SNR than the plus 10 dB SNR condition for both average and short RT when the distractor is in the right ear. This could be because the spatial release from masking cue is used only in more demanding situations when other cues are not available, and also could be due to the right ear advantage. Supporting studies show that at lower SNR, the spatial separation is particularly beneficial because it helps the listeners isolate the target signal from the dominant noise. And other studies showed that the SNR value needed to understand speech in noise in the right ear was statistically significantly lower than the left ear. Coming to the clinical implications, this study helps to identify specific acoustic challenges in classroom situations. It helps in preparing individual education plans. It helps in assessment and management of disorders such as CAPD, dyslexia, etc. In case of disability, this study shows guidelines for the government for policy making. Looking at the conclusion, this study highlights that the interaction between SNR, RT, and distracted position significantly influences the speech recognition in school going children, and we can see right ear spatial advantage at lower SNR and average reverberation time. And these results emphasize the need for optimal classroom acoustics, especially in noisy levels and spatial layout, to facilitate effective learning in children. Thank you.